Traditionally, rockets are made with metals such as aluminum and steel. Metal is great but carries weight.
While building a rocket to carry small satellites, we have to make sure that it has to be light and nimble like a sports car. To reach orbit with a rocket the size of Vikram 1, we needed strength to weight ratio that metals couldn't offer.
In fact, we had to look beyond natural materials.
Composites are an engineering magic. You take fine strands of carbon fiber, mix it with a special resin, weave them and process it. You get a structure that is stronger than metal at a fraction of weight.
And a lighter structure means you get a more efficient rocket, which is perfect for small satellites.
That's theory. But building with composites is not that easy. It demands diligence. We had to design the entire process. How do we weave these fibers together like a matrix? In what directions do we weave them? And how we can avoid air bubbles or misalignments. We had to design the curing process as well. Curing process is like putting this carbon composite in a pressure cooker, applying the right heat, right pressure, and these carbon composite becomes tougher than metal.
And we had to develop and master multiple composite manufacturing methods. The stages of the rocket are made by winding the carbon fiber using a special automated machine.
Some sections of our rocket needed further strengthening, so we made a sandwich using composites in which 2 layers of carbon composites are bonded on the either side of the honeycomb structure.
And then came a different challenge, heat. To protect the rockets during ascent, we needed something to take the heat, but without adding too much weight.
So we turned to nature and found the answer in bark. Cork sheets made from bark of oak trees are lightweight with tiny air pockets in them.
And by laying them over a composite structure, we can protect the rocket from the atmospheric heat. It's the same stuff you'll find in the cricket ball, only here it's protecting a rocket.
Each of these steps demand extreme diligence. A small bubble, a wrong ratio of fiber and resin, or a small deviation in the temperature while curing, and that part doesn't fly. With composites, we weren't just building structure of the rocket. We were in a way creating entire design and engineering philosophy. Lightweight composites gave our rocket its frame.
Now it was time to add the real firepower.